So this video is going to be some examples of derivatives. So we're going to start with the function y equals 7, and I'm going to rewrite this function. Now a lot of these functions you do not need to rewrite because you can just look at them and see what the derivative is. For example, I know the derivative of y can be written as dy dx or y prime, and 7 is a constant, so I know my final answer could be y prime equals 0, but I want to show you this with the power rule. So I could say that this 7 is really 7x to the 0 power, because x to the 0 is 1. So then I could take the derivative, multiply down, and you can see that I'm multiplying this 7 by a 0. So it would be 0 times 7x, and then I'd subtract 1, and it's a little ridiculous because anything you multiply by 0 here is going to be 0. So the derivative of the 7 is 0, and then I'm going to say y prime equals 0. Make sure that if you start with an equation, you end with an equation. I could also have written this as dy dx, the derivative of y with respect to x, equals 0. The next function would be f of x equals 0, which again I could go straight to the answer, but it would work the same way. This is really like 0 times x to the 0. Take my 0, multiply it down, and now I have 0 times x to the negative 1. The way I'm going to write the derivative of f of x is f prime of x equals 0. And that would be the answer. For the next problem, what if you have s of t? So our independent variable is t, probably standing for time, equals -3. Then the difference between this one and this one is very simply, this would be -3 times t to the 0, which won't matter for this problem, but later you really need to pay attention to variables. So when I take this 0, multiply it down, I am again going to get 0, but the way I'll write the derivative of this would be s prime of t equals 0. For my next example, we're getting out of the constant, so we're going to say f of x equals x cubed. If I rewrote that, I would say that this is really 1x cubed. So I'm going to take my 3, multiply it down, so that's a 3x, and then I'm going to drop the power by 1 squared. So I would write f prime of x equals 3x squared, and that's the derivative. For the next problem, f of x equals just plain x. I could rewrite it as 1x to the first. I take my 1, multiply it down, it's 1x to the 1 minus 1. Well, when I subtract 1, I get x to the 0. X to the 0 is 1. So this will be f prime of x equals 1, which should make sense because f of x equals x is a linear function. The coefficient of the linear function is the slope. So my derivative is 1 for that function all the time. For my next problem, we're really looking at just making sure we understand exponents and all the rules that go with them. So let's say we have f of x equals the cube root of x. If I rewrote that, I'm going to say I have an x, but if you look inside the cube root, that's like an x to the first. So here's my power, and then this 3 is my root. So it's going to go to the bottom part of the fraction. Now when I do the power rule, I'm going to take my 1/3, multiply it by the 1 coefficient, so I have a 1/3 x, and then I'm going to subtract 1. Remember that you have to have a common denominator, so I'm going to subtract 3/3 on my exponent. 1/3 minus 3/3 is a -2/3, which is fine and it's right, but I don't want any fractional or negative exponents in my answer. So I'm going to rewrite this again, and I'm going to say f prime of x equals, and just take it very slowly. This 1 is in the numerator, the 3 is in the denominator. The negative exponent puts x in the denominator. It's to the second power, and I'm taking the cube root. So there's a lot going on. Again, the 1's in the numerator, the 3's in the denominator. Negative exponents move things across the fraction bar. This will be the power on my x, this will be the root. And just a quick reminder about the negative exponents. If you have x squared divided by x to the fifth, we know that simplifies to 1 over x to the third because two of your x's will cancel out. Our rules of exponents say that if you divide two things with the same base, we'll subtract our exponents. So this is the same thing as x to the 2 minus 5, which is equal to x to the negative 3. So these two are equivalent, and you can see a negative puts it underneath the fraction bar. So this would be our answer for the derivative.